Hello, my name is Muhammad Amir Luqman bin Suaimi. My matrix number is 33 DPE 19F 1013. So today I will present to you about our assignment, which is about heat exchanger. So the question I choose is from number 8, fire heaters. Today I will explain to you basic concept of heat exchanger as working principles and law mean temperature difference method LMTD. So for working principle, the term fire heater get used in many ways and what it actually means can get ambiguous. We define a fire heater as direct fire heat exchangers that use hot combustion gases, flue gases, to raise the temperature of a process fluid flowing through the coils arranged inside the heater. This definition is consistent with that found in MPI Standards 560, which is fire heaters for general refinery service, which states a fire heater is an exchanger that transfers heat from combustion of fuel to fluids contained in tubular coils within an internally insulated enclosure. For the purposes of this discussion, direct fire heater, process heater and furnace are considered synonymous and will be used interchangeably. Note that other types of fire equipment like fire tube, water bath and indirect heaters do not fit within this definition. So radiation and convection are the two primary means of heat transfer that occur inside a fire heater. They each occur in different areas of the heater, appropriately named the radiant section and the convection section. Each section is internally insulated with brick, castable or ceramic fiber refractory and houses its own a coil which carries the fluid being heated. Log mean temperature difference method LMTD. The log temperature difference LMTD is used to determine the temperature driving force for heat transfer in flow system. Most notably in heat exchangers, the LMTD is a logarithmic average of the temperature difference between the hot and cold stream at each end of the exchanger. The larger the LMTD, the more heat is transferred. The use of the LMTDs arises straightforwardly from the analysis of a heat exchanger with constant flow rate and fluid thermal properties. So the second one is the question number 2 is types of heat exchanger based on working principle, construction, components, advantages and disadvantages, and my reference. So working principle is direct fire combustion equipment is that in which the flame and or product of combustion are used to achieve the desired result by radiation and convection. Common examples include rotary kilns and open hearth furnace. Indirect fire combustion equipment is that in which the flame and products of combustion are separated from any contact with the principal material in the process by metallic or refractory walls. Example, steam boiler, vaporizers, heat exchangers, and melting pots. The heat exchanger previously discussed rely on convection and conduction for heat transfer. In a fixed heater, such as shown in figure 3-19, radiation plays a major role in heat transfer. The process fluid flows through tubes around a flame. These tubes receive most of the heat directly by radiation from the flame. A small amount of heat is also received by convection from the air between the tubes and flame. Heaters are not common in most field installations but are much more commonly used in plant situations in which component operators routinely maintain and inspect the equipment. The tubes that are around the flame get most of their heat energy from radiation. The tubes in the top of the chamber get their heat from convection as the hot exhaust gas rises up through the heater and heat process fluid in the tubes. The principal classification of fire heaters related to the orientation of the heating coil in the radiation section. The tube coils of vertical feed heaters are placed vertically along the walls of the combustion chamber. Firing also occurs vertically from the floor of the heater. All the tubes are subjected to radiant energy. Okay, the radiation section tube coils of horizontal feed heaters are arranged horizontally so as to line the side walls and the roof of the combustion chamber. In addition, there is convection section of tube coils which are positioned as a horizontal bank of tube above the combustion chamber. Normally, the tubes are fixed vertically from the floor, but they can also fire horizontally by sidewall mounted burners located below the tube coil. This economical high-efficiency design currently represents the majority of new horizontal tube feed fire heater installation. Duties run from 5 to 250 MMBTU per hour. 6 types of horizontal tube feed heater are shown in figure 3.21. So the construction is a direct fire heater is a style of heater in which a burner provides hot gases that transfer their heat energy to a processed liquid or gas flowing directly through coils installed inside the heater vessel. Direct fire heaters can utilize radiant and or convection heat transfer section and can be configured in many different ways depending on the customer's specific requirements. Due to the flexibility in design, virtually any style of furnace burner can be used in a single or multi-burner configuration. For help selecting the right solution for your project, contact our application engineers today. A convection style heater offers the benefit of a direct fire heater while eliminating some of the drawbacks associated with radiant heat transfer. Radiant heat transfer can be undesirable in certain temperature-sensitive applications as radiant heat transfer tend to be more intense and unevenly distributed around the coil surface. So the component is burners are critical device installed in a heater that generate the energy absorbed by the fluid moving through the radiant and convection coil. They do this by mixing the proper ratio of air and fuel, providing stable combustion and appropriately directing flame. As discussed in our first post, burners can be with so many burners arrangement. It should be no surprise that burners themselves come in a variety of design. We all explore basic combustion theory and burners design in next month's post. The radiation coil carries the process fluid through the radiant section. As radiant heat is the primary energy transfer mechanism in this heater section, this coil have bar tubes. Example, no extended surface are attached. The convection coil carries the fluid being heated through the convection section. A key difference between convection and radiant coils is the most tubes that make up the convection coils have an extended surface. The additional surface area improves convective heat transfer and increased thermal efficiency. Example of common extended surface use include continuous fins, serrated fins, and studs. So, the function of stud is the stud collects the fluid gas and discharge to the atmosphere. Sample post nozzles near the stud exits where sampling probes or other sensors are inserted to measure fluid gas composition, pressure, and or temperature. For stud damper, a valve located inside the stud used to control flow of fluid gas and adjust draft. For header box, a refractory line box covering the return bands and separated from the fluid gas flow. And for return bands, U-shaped fittings connecting tubes in the convection coil. Tube sheet, support sheet for convection tubes passing through it. And expansion rows. For the last one, space left in the convection section for the future addition of rows. The last one is advantages and disadvantages. Advantages is fresh air, clean air. You don't have to worry about breathing in toxic elements such as carbon monoxide or gas. Because of this, you can place this heater in a wider variety of space, even those without significant ventilation. The second one is maximum recirculation. One of the best ways to save money on a heater is to keep the air recirculating inside. The last one is precise thermostat control. It's like your home furnace. You can set the ambient temperature accurately without worrying about the space getting too hot or cold. So the disadvantages is less of fuel efficient. Since the flame is not touching open air, about 20% of the heat is lost in the transfer. The second one is ventilation that's required. Although you can place this heater in tight quarters, you will have no ventilate the combustion part. The third one is higher rental costs. These models are much more complicated than direct fire units, so you will have to pay more for rental. The last one is substational electrical requirement. If your event or work site is outdoor, you will need to have a generator to run the machine. So this is my reference for my research. So that's all from me. Thank you.